This is Mission Specialist Nicholas Pillai, Mission Science Officer Lilith Karthikeyan. Are the resources in place?
Yeah, everything is perfect.
Noted. Mission Pilot Avani Abhilash Soni. Are our propulsion systems in check?
Yes, sir, we're ready to go.
Thank you. Mission Commander Ashwin S. Hope is ready to take off.
Minutes ago. Good morning, respected judges. 2 weeks ago, we were five individuals going to the diurnal rhythms of our day-to-day life. 2 weeks later, the daunting task of space colonization brought us together and we became the Astroholics. Fiction or reality, as long as something had a scientific base, it had our curiosity. And it is with this curiosity and love for science that we decided to compete in this event against all other brilliantly talented individuals. So now, first let's look into the mission schedule. This is the order in which we will be explaining the mission to you. So let's start with the most fundamental question before colonizing a moon or a Titan or planet, which is why to colonize. I'm going to be giving the stage to Avani to explain the same. Avani, please.
Thank you, Ashwin. So let us go answer Ashwin's question. Why exactly are we colonizing space? In fact, there are numerous reasons to why we'll opt for colonization. And the usual reasons are overpopulation. But there are literally more to it. So colonization does help us to bolster population expansion. But the solution for overpopulation has to be found within Earth itself. So let us consider some other aspects. Human beings are driven to explore, and exploration can definitely be a reason for colonization, and it will eventually lead us to some planet that are capable of sustaining life. This will ensure a long term survival of our species. Moreover, there are abundant resources beyond Earth. If we have access to these resources, then it will improve our society and our economy. And this will also provide us new forms of commercialization like asteroid mining, solar power satellites, space manufacturing, etc. So, considering all these facts, we have looked for some moons and planets, and we have decided to crown Saturn's moon Titan as our new home. But why exactly have we chosen Titan? And this will be discussed by Ashwin in the next section.
Thank you, Avani. So now let's look at the reasons why we have chosen Titan. Actually, we have researched many planets and bodies inside and out of our solar system. We realize that exoplanets are unimaginably far away from us, and we will not be able to reach there in one lifetime. The terrestrial planets inside our solar system have extreme climatic conditions due to which they are inhospitable. The common candidates like Moon and the Mars lack certain characters like an atmosphere or a magnetosphere, which are necessary for a self-sustaining society. Now, the next option was the moons of Saturn and Jupiter. The moon with most potential for this is Titan, the largest moon of Saturn. It has a liquid system with a change that methane and ethane are in place of water. It is a dynamic world with different geological features due to the methane-based hydrologic cycle. It is protected from the solar winds and radiations by the magnetosphere of Saturn. Vast quantities of organic compounds are present in Titan. There is also chances of vast quantity of water to be present underground. It has a dense atmosphere of 1.5 times the atmospheric pressure here on Earth. The chances for life to be found on Titan is also very high, underground in the water or in different ways, which we have never actually seen on the hydrocarbon lakes of Titan. The one another reason why we chose Titan is because of the relative closeness compared to the exoplanets. The next thing is that the place we are going to be landing and setting up Camp Perseus is near Kraken Mare, which is the largest hydrocarbon lake near the North Pole of Titan. The reason for this is to utilize the hydrocarbon lake to its maximum in research, energy generation, etc. Now I'm going to be handing the stage back to Avani to explain the plan for starting a civilization. Avani, please.
Thank you again. So, let me just guide you through how exactly we're planning to execute the whole implementation process in Titan. So, please do take part in our little Hope mission. So, Hope will be divided into a total of three phases. The first phase will include the launching of a rotorcraft. The second phase will include the implementation of a first manned mission. And the third phase will allow us to reach to self-sustenance. Now, let us get a bit in detail with phase one. So, like I've mentioned earlier, we'll be sending a rotorcraft first. And to be more precise, the rotorcraft is like a quadcopter, and we'll name it as a Renaissance. And it will be landing near Kraken Mare. And before we go further, let us discuss a few features of renaissance. So it will be provided with a high-gain antenna for direct-to-earth communication. Along with that, it will be provided with propellers for propagation as well as descending. The reason for choosing an aerial mode of transportation will be explained by Ashwin in the last section. And coming back, it will be also assisted with parachutes during the time of descent. And Renaissance will be run on RTG fuel, and it will also be provided with a high resolution camera for proper imaging of our new planet. But why exactly are we sending Renaissance first? It is simple. We do need accurate atmospheric data and other data from Titan, so it will just go and make arrangements for the manned crew. And side by side, it is also programmed to search for existing life because Titan does have a high chance of life already existing in it. Now, once we get a green signal, we'll be sending a Primeval rocket launch with necessary infrastructure materials for building a temporary base so that the manned crew can settle on it. And with that, the phase 1 comes to an end. Now, let's see what phase 2 has for us. So, phase 2 is when the first crew lands over to Titan. They will utilize the in situ resources and develop a life support mechanism, food, energy, waste, and all the other small scale necessities. And this will be elaborated in the whole session. And phase 3 is where we aim for self sustenance. So, can we have that slide? Thank you. Now, every 7 years, we'll be sending additional workforce as well as necessary gadgets over to Titan. And with the first launch, we'll be having a total of approximately 10 members. For the second launch, we'll have approximately 20. And for third launch, we'll be having about 30. And we are aiming for a minimum population of about 100 in Titan. And the rest of the population will be produced therein. And this population can contribute in the expansion of the civilization as well as to maintain a stable population over Titan. So that is where my phase 3 ends. So let us get an in detail view of the projects that we're going to conduct on Titan. So we'll begin with habitation. So I'll be handing over the stage to Vaishnavi. Thank you.
I'll be walking you through how we'll be turning the barren lands of Titan into habitable zones. Titan is 10 times farther from the sun and receives 100 times less solar energy. This moon of Saturn has its own hydrological cycles, much like that of Earth, with liquids of methane falling from the sky and evaporating back into the clouds. The most obvious conclusion that can be made from these facts would be that the weather and atmospheric variations of Titan from that of Earth are stark. To combat this hurdle, a triple-layered system of domes would be implemented, which structurally resemble the carbon compound Buckminster fullerene. The selection of this arrangement serves two purposes. Firstly, it would provide structural support to the system, and second, installation of pipes throughout the domes would enable a system of functional transportation. The outer and inner walls would be made out of PTFE, an extremely versatile, affordable, and light synthetic polymer well known for its high chemical, thermal, flame, and weathering resistance. Silica aerogel, the lightest artificial material, would be packed between these layers. The light weight of this material would enable feasible transport and facile administration. Furthermore, containing heat and protecting life forms from inside the harsh weather conditions. Based on the purposes served by them, the domes on Titan are broadly classified into four types: the living quarters, the storage and industrial units, the farms, and the medical dome. The surface pressure of Titan is 50% higher than that of Earth. This variation would adversely affect the efficiency of treatments of cuts and wounds. A vacuum oxygen cycle would therefore be administered in the surgical theater of the medical dome as a pressure neutralizer. As the popular saying goes, vacuum does not discriminate. Our vacuum pump would suck out and every presence of air out of the room. Oxygen would then be separated from the extracted air and transferred back into the room, thus forming a loop. Can we have the next slide, please? Thank you. As much as our planet is blessed with the presence of bright sunlight, Titan is jinxed with its absence. To reduce the consumption of electricity and conserve our resources from the very beginning, we've come up with a new system of light generation. The illumination generator, an in situ transmitting entity, Project Ignite, functions as reminiscence of the human circulatory system, wherein the solution of a chemical luminol is transported to all the domes in the form of liquid light via pipes. Under normal circumstances, the potency of this liquid would drop after a few seconds, thus making it appear dull or faint. To counter this problem, this liquid would be carried back to the system and heated, thus causing hydrogen peroxide to disintegrate into water and oxygen. As materials of vital importance, these obtained compounds would be collected and sent back to the storage units to put them to right use. Fresh hydrogen peroxide from the waste management plant would then mix with a refined semi-solid obtained after filtration, which would then be carried to the respective domes, thus forming a self-sustaining system of light generation. The Sustenance and Transference Enabling Mechanism, Project STEM, broadly covers the production and provision of food materials throughout the civilization, utilizing the scientific mechanism of aeroponics, which would permit us to grow an extensive variety of crops. Plants would be provided all the necessary materials required for growth in the form of mist. Tholin, an organic compound, would be extracted from the surface of Titan and subjected to high pressure and heat to break it down into its substituents, that is, amino acids, water, carbon dioxide, and hydrocarbons. These are mixed in a chamber and transported to the farms, undergoing condensation and mixed with water. Carbon dioxide would be added to the mixture to support the light phase of photosynthesis, and oxygen would be added to sustain the dark phase. Fertilizers are produced by combining the abundantly available resource of nitrogen with amino acids, urea from the waste management plant, and small amounts of phosphorus and potassium, which is then transported to the farms undergoing condensation. They are accumulated in a tank, mixed with water, and sent to the plants in the form of mist. The water molecules released after transpiration would be collected back in the moisture reabsorbing chamber through a permeable laminate made of silica gel. The accumulated water is then directed back into the water tank that supplies water to STEM. Additional water, if need arises, will be provided from the light generation plant. The chamber is heated so as to aid the silica gel attain its properties anew, thus creating a self-sustaining cycle of food production. Also, water is pumped from the subsurface ocean present below the crust, after which it will undergo a rigorous filtration process so as to make it potable. To answer more pressing questions on how artificial sunlight would be produced to sustain agriculture and elucidate on the carbon and oxygen cycles, I would hand over the mic to Nikhil. Thank you.
Thank you, Vaishnavi. So, as my teammates have already mentioned, sunlight is not a viable resource for agriculture on Titan. So, we will be using incandescent light bulbs for artificial light. We will be using carbon nanotube coated carbon filaments instead of the conventional metallic filaments, and they are actually more efficient and exhibit greater luminance than the latter. We'll also be covering the inner surface of the domes with a light reflecting material so as to better utilize the light. Now we'll be moving on to removal of carbon dioxide. Can we have that slide, please? Okay, thank you. So for CO2 removal, the method that we have opted is called amine scrubbing. So the reason why we have chosen this method is that the raw materials needed for the solvents involved in this process, which are DEA and MEA, can be produced locally on Titan. Also, this process is reversible and hence it is sustainable, efficient, and definitely not resource intensive. The chemical reaction involved in this process has been given on screen for your perusal. And with that, we'll be moving on to gravity. So the effects of abnormal gravity are adverse and well known. So in order to counter this, the inhabitants on Titan will have to exercise regularly. But to make this more effective, we will be using a rotating room to generate artificial gravity, similar to the one at the Ashton Gabriel Spatial Orientation Laboratory at Brandeis University. And now I'll be walking you through our manufacturing process, and I'll also be enumerating the various materials that we'll produce on Titan and use on Titan. So manufacturing will be carried out inside two industrial domes. One will deal with the processing of raw materials and the other will deal with the manufacturing of finished goods. It will have appropriate subdivisions based on the number and types of good produced. Also, the basic structure of these industrial domes will be similar to that of our living quarters in the sense that they will have the same systems of oxygen supply and carbon dioxide removal, but on a larger scale. Now, let's take a glance at storms, our subterranean oxygen and related resource mining system. So Titan's atmosphere does not possess viable amounts of oxygen. So we decided to utilize the global subsurface ocean. Through pipes and pumps, we will be feeding the water into an electrolysis chamber where it will be split into hydrogen, oxygen, and other by-products. Now, keeping in mind that the water on Titan is extremely salty, we will be using a high oxygen anode so as to maximize oxygen production and minimize chlorine and chlorates production. The oxygen produced will be appropriately stored and it will be sent to the domes where it will be mixed with nitrogen so as to prevent oxygen toxicity. It will also be stored inside portable canisters to be used inside spacesuits and vehicles. The hydrogen produced will be stored and can be used as an alternative fuel. Can we have the next slide, please? Okay, so here we have the list of the materials that will be produced on Titan and a few of their uses. So the first material here is carbon fiber. So carbon fiber is a material that has a variety of advantages that include, but is not limited to, high tensile strength, low thermal expansion, etc. It is an increasingly popular substitute to steel, and it can be used to manufacture the frames of various structures, parts of large appliances, and even all carbon automobile engines, which will be discussed further later on. Next, we have carbon nanotubes. So naturally, we will require conducting wires on Titan, and this role will be taken up by carbon nanotubes. They are just as efficient as the conventional wires and are actually stronger and more flexible. And the primary fabric that will be used to make clothes for our inhabitants on Titan will be polyester. They are cheap, easy to produce, durable, albeit a little uncomfortable. The immense amounts of hydrocarbons on Titan make polyester clothes the perfect candidate for mass production. However, we did not turn a blind eye to the discomfort of our people there. So that is why we will be using sodium hydroxide from storms and cellulose from the agricultural waste to produce rayon, which is a more comfortable alternative for to polyester. Then, of course, we have plastic. So plastics are very versatile and can be used to manufacture any number of articles for both daily as well as industrial purposes. The wealth of hydrocarbons on Titan makes plastics an excellent choice. And after this, we have silica. So the surface of Titan has mineable silica, which can be used to produce a variety of goods. For instance, silica aerosol, which is a thermal insulator. And using silicone from silica and a little bit of plastic, we can even manufacture computer chips on Titan. Next, we have fullerene. So fullerene is an organic compound present in the atmosphere of Titan, and this is our more efficient alternative to the metal catalyst used in hydrogen peroxide production, which is required for our light generation system. And finally, we have chlorine. So it is a byproduct of storms, and it has a variety of uses. The most practical of which being the production of polyvinyl chloride or PVC. PVC can be used to make transportation pipes for fluids. It can also be used to manufacture footwear, wire insulators, and medical devices, and so on. And with that, I'll be handing over the mic to Lilith Karthikeyan, who will illustrate how energy can be generated on site.
Thank you, Nick. Energy generation. Whenever it comes to colonization, energy generation is of vital importance. Luckily, Titan is just filled with resources, hydrogen, and other hydrocarbons. Now, let us look into different methods for production of by utilizing. The first method involves tidal energy. Kraken, the largest liquid body found in Titan, has a narrow constriction index called Selden-Pittam. Here, tides and water currents are created due to Titan's orbital eccentricity. So, setting up of efficient turbines would be of great use here. Next in the line is nuclear energy. According to the sources, about 50% of Titan surface is covered with silicate. As radioactive materials can be extracted from silicate rocks, nuclear power plants can be set up in Titan. These nuclear power plants will be maintained by artificial robots, which will keep a check on radiation level, temperature, and etc. The next method is thermal cracking. Liquid methane from Kraken is transported to a power plant where it is converted to gas first, and then the thermal energy from nuclear power plant is provided to the reactor. When the temperature reaches 300 degrees Celsius, the methane starts splitting into carbon and hydrogen. After further purification, this hydrogen gas can be used in the production of fuel. Next is power distribution and management. Distribution system is the link through which any consumer can draw electricity from the power system. About 30 to 35% of the energy produced will be stored in batteries. A battery model based on plastic polymer electrolyte will be used for this purpose. The advantage of using plastic polymer electrolyte batteries is that they won't explode in case of overcharge like lithium-ion batteries, as plastic is a flame retardant. The energy generated from all power plants will then be transported to substation where voltage is regulated, and then from here the energy is distributed to all shelter and industrial domes. Carbon nanotubes will be used for transporting electricity instead of metallic wire. The next idea is wireless energy transition. Idea began with Tesla in 1890s, and several other industries are working on this project right now. One such industry is Emerald in New Zealand, and they claim that they are on the verge of completing the process. This process will require two components. One is a transmitter and the other one is receiver. The transmitter converts the electrical energy into electromagnetic radiation and then shapes it into a cylindrical beam, which is then directed towards the receiver. And then this receiver again converts the radiation back into electricity. The efficiency rate is around 70%. In case of any disruption in power distribution, the power supply to all shelter and industrial domes will be cut off, and all humans will be evacuated to a main hub where they will be living temporarily till the situation. Next is waste management. The process mentioned before would create a lot of waste, and under this section, let us look into different methods for managing and recycling. The first type of waste is nuclear waste, and the method that can be used is delay and decay. Gases that are radioactive will be stored for a period of time, and then later on, when they are no longer considered as radioactive, they will be released back into the environment after proper filtering. Radioactive materials will be collected and stored in an interim zone, which will be located far away from settlements. The next type of waste is electronic waste. Damaged electrical gadgets are dismantled, and the components like chips, circuit boards are separated from it, and they can be recycled or repaired based on their condition. The last type of waste include biological waste. Biological waste from the shelter dome will be collected and transported to a biogas power plant, which of course will produce biogas. It can be used in the process of cooking or as a source of thermal energy. Human excrete and other biological waste can be used in the production of hydrogen peroxide. But this process would require electrocatalysis. Currently in Earth, noble metal-based electrocatalysts like platinum, gold are used for this purpose, but the cost of production is really high. But in Titan, we can use a hybrid of fullerene-60 and carbon nanotubes as electrocatalysts. The hydrogen peroxide produced in this plant will then be transported to Ignite, which is the light generation plant. There, after certain reaction, oxygen and water are produced as byproducts. From here, my friend Ashwin will be discussing different ideas for communication and transport. Thank you.
Lalit, now that we have understood about energy generation and its distribution, let's look into two important topics, which is transportation and communication. Both are essential for a civilization. First, let's look into transportation. The thing to be noted in Titan is that the weight of vehicles or anything will be 1/10 of what it is on Earth, meaning the friction it experiences will also be less. So we won't be able to maneuver cars or bikes on Titan. So we needed to find a more efficient and better way of transport. This is why we have selected the hovercraft. Hovercraft is also called an air cushion vehicle. It uses a cushion of air to glide over surfaces with negligible friction. So this is perfect for Titan, as Titan also has a dense atmosphere. Now, this is going to be produced completely on Titan. Its body is going to be made out of carbon fiber. Its wirings are going to be made out of carbon nanotubes. Its engine is actually going to be an electrical engine made out of carbon fiber. Ford has already made a prototype for a carbon fiber engine. The only change is that it's a combustion engine. So we are expecting in a few years that electrical engines will also be made using carbon fiber. The next thing to note is that the energy for this vehicle will come through the wireless transmission, which Lalit has already mentioned. There will be a receiver in on the hovercraft. When it's out of the range of the transmission, it will be using the plastic polymer electrolyte and also hydrogen fuel cells for energy generation. The cabin where the passengers will be made out of PTFE and silica aerogel, just like our domes. It will contain to encapsulate most of the heat. Fan heaters will also be added to the cabin, and oxygen will be available to the crew through canisters which have been already filled from the base. Now, the two pictures in the side actually represent a few hypothetical ways of travel on Titan, which is only possible on Titan. For example, we may be able to fly like birds on Titan if we were to attach wings to our suit. The reason is the low gravity and the dense atmosphere. So this is just an example of the many things which we consider fantasy on Earth, which could be possible on Titan. Now let's look into the final topic, which is communication. This is like I said, it's an important topic. There are four ways in which we are planning for the people to be able to communicate. They are through the use of cellular technology, satellite phones, through the use of radios, and through internet. The cellular technology is pretty straightforward. We are all using it in an everyday basis. It works through a network of cell towers which connects everyone. The satellite phones actually use satellites to which it sends a signal, which sends it to a gateway or a land-based center. Through it, the signal is sent to the person who is being called. Radios will be used for communication between the people wearing the special suit, as it will not be possible for them to communicate normally. Now, the last one is the internet facilities. We all know we can't live with internet these days, and truthfully, this is a daunting task to recreate the internet on Titan, because internet works by a network of data centers which are connected through optical fiber cables. So we will have to replicate the data centers on Earth on Titan. So this is a daunting task. Now let's look into the plan for establishing communication. This has three phases. The first phase is when the first Titanians, the first crew reaches there. They'll be communicating completely through radios. The satellite, which has been already sent to scout the region near Kraken Mare, will act as a relay point through which they will be able to communicate to Earth. The second phase is when the spaceships bring more and more people to Titan. These spaceships will contain specialized satellites which can act as data centers. They will be constantly in touch with the data centers on Earth and updating each other. The third phase is when the civilization has expanded and more area has been covered on Titan. Then cell towers start coming in, and communication becomes more and more like on Earth, with data centers also coming on the ground. With this, our our mission Hope is coming to an end. I would like to thank the organizers for giving us this opportunity to test our curiosity, and also the judges who have patiently listened to us. Thank you.